and I can start my presentation.
Yeah.
Yeah, so welcome to my talk here on dynamic strategic modeling for alliance-driven data platforms, the case of smart platforms. Yeah, my name is István, and this is still joint work with colleagues Stefan and Matthias Jarke from Information Systems, as well as Economics Institute, Marc at RWTH Aachen University. And to jump right into the topic, yeah, we know, and you also heard this morning, that digital transformation is, well, changing value change and for industrial organizations because of a lot of data is generated. And to deal with that, organizations increasingly rely on external service and data exchange. And there are platforms, ecosystems that evolve that connect these stakeholders for data sharing. And there is, that usually happens with a central orchestrator, also responsible for platform operation. But recently there are multi-sided new platform type models. For example, the alliance-driven platforms, where players, they join together to create and capture value. And to research that in our research cluster here in the university, we looked at a large case study from the economics partners in smart agriculture. And therefore, we propose a combination of strategic conceptual modeling with the ISTAR language and the control points from the economics perspective that I will explain in a minute. And so we synthesize these economic and computer science perspectives. So in the platform literature, there are various approaches where with platform orchestrators as the de facto leaders, and also new types where innovation is created jointly. And in fact, on the other side, in information systems, we already inherently deal with networks of interfaces, libraries, resellers, and so on. So we have some approaches there already, like software supply networks or the product deployment context. And last but not least, the ISTAR modeling, which, well, helps making relationships explicit, facilitates exploring strategies, and also supports systematic reasoning. And that's what we did in this context. So based on the case study of over 100 hours of interviews and 55 partners in agriculture, we distilled some number of ISTAR models. So there is one, the strategic dependency model. And for example, here you see the actors, for example, the manufacturer and the dealers and the farmers. And just one example, the dealer depends on the manufacturer in order to sell machines. Another one, farm platform depends on the contractor for machine data. And from these models alone, we already got some insights that we can generalize. For example, that a too strong tie to a particular platform can lead to monopoly. And also note the dependency cycles that I'm showing here, for example. That is a prerequisite for new types of interdependent alliance-driven platform models. The other aspect that we use is setting control points. And control points, there are technical and strategic decisions that companies can set to impose certain behavior. So for example, here coming from a pipeline business model, you can set the control point of modularization to decouple the hardware from the services that can run on the hardware, and you get to this value capture. And then if you open up further, you can get to this part where you have, you can share your data on platforms. And here in this case, that is the one dominant platform, for example. So these are decisions that an organization can take to impose certain strategies. And we claim that the right configuration helps to indicate viable transition paths within the platform ecosystems. as the discussion. So we found the I-star notation, the conceptual model that was found superior by our economics partners because they're used to write long textual descriptions, so they like that. And also we found that the combination of the models and these control points maps quite well to the concepts of the international data spaces you might remember from last year's keynote by Professor Jarke, where we have also the data providers and the consumers and some concepts like clearinghouse for establishing trust between the partners. As a next step, we want to create these policies automatically and also create a repository of visual representations to help the organizations to impose the strategies, and also what they're eagerly waiting for are agent-based simulations of business models where they can play around. That's it. Thank you for your attention. And there are some links here, and I'm also open for questions here.
Thank you, István. Any questions? Seems to be very fascinating. So kind of the vision is that this will be all fully automated in the end, or is what's the human component in that approach?
We don't think that it can be or should be fully automated. So we still need the intelligence from the humans here. But we want to have some decision support instruments so that you can try out and simulate new configurations, also check whether a certain interface to your data makes sense at all. What implications does it have financially or socio-technically?
Mm-hmm. Any other questions? So this I-star modeling language, that comes from the software engineering context, or where does that come from?
That comes from Eric Yu in his dissertation in Toronto, and that's from requirements engineering. So that's about strategic conceptual modeling for strategic requirements engineering. Yeah, and there are various extensions. And also there is now a new one with combining game theory, so you can play game trees, like look at the constellations between the actors. So that is highly interesting for this data space driven research.
Mm-hmm. Yeah. Any other thoughts or comments from the audience? All right, if that's not the case, so I think we're through the first round of presentations. So that's the ideal point in time for any audience members who would like to move to another room. So please presenters stay here, we need you. So I would expect that Selmin and Yanis in the other rooms are probably announcing the same thing around this time. So hopefully we'll get a bit of moving around by the audience. And I guess we then start the next round and come back again to Sebastian.
Okay. I'll share my screen again. Is it visible?
Yes.
All right. Yeah, so there we go again. Thanks everyone for attending. Co-presenters for the second time. This is about this work that I'm presenting is about data-driven process performance measurement and also prediction. There's a typo in the program. It should be prediction, not production. And this is a process tree-based approach. So we use process trees as our process modeling formalism. This is joint work with my co-authors, Luis Santos, who is also here in the room, and Will van der Aalst, who couldn't join today, sadly. And my name is Sebastian. Both Will and I are affiliated with Fraunhofer FIT as well as the RWTH Aachen University, and Luis is affiliated with the RWTH Aachen University. So the work that we present here is in context of process mining, and what you should know about that is that the physical processes we execute in the real world, they leave digital footprints of data tracking basically the historical execution of said processes, which we often refer to as event logs. And these event logs, schematically depicted in this slide, they act as the starting point of the technique that we propose in this paper. So the technique looks schematically as follows. We take a given event log, so a given recording of the historical executions of a process, and we also take a process model that represents that process, in this case modeled as a process tree. And then first of all, we quantify the performance of the process as recorded by the event data in the context of the process model. And the nice thing is that the framework uses alignments to do that. And that's nice, because that means that the process model and the event log do not necessarily have to correspond perfectly to each other. So it can be that certain behavior in the event log is not really described by the model, or vice versa. We can use that annotated process model to then, create hypotheses about future performance that we would like to have. And we can inject those performance changes of the form, what would happen if I reduce the service time of this or that activity. And it's important to note that these computations are in a way replaying the event data that is captured with an alternative execution time of a certain activity or a subpart of the model. And furthermore, it's important to note that you can stack these different changes on top of each other. And this is implemented in the PM4PY framework, of which I am the I am the founder of that thing. Then this is actually online available. Please go to github.com/luisfsts/KPI algebras. There's the repo that contains the source code that I'm also actively using in this short demo, which I have prepared for this session. What you see here is a process model that models the road finds traffic data set that is uploaded somewhere a few years ago by Massimiliano De Leoni. And you see the colored elements of this process tree. Those are colored based on the performance. And yellow means it's going well, and red means it's not going so well. It's slower. Well, I don't have time to explain the semantics of this process tree, but in general, this is a largely sequential process where there's a lot of optional behavior. What we, for example, see in the bottom is a large subtree with white elements. That means that these elements actually have not been observed in the data set that I'm using for the process overlay. This is a sample also due to performance reasons of the tool. What I've also showed previous demos, so why not do it again? No, let's do something different today. So I can, for example, if I want, I can decrease the performance of, or let's say increase the performance of the send fine activity. We see it's a darker orange than, for example, the add penalty. So if I search for the send fine activity in my overview of this model, I see that at the moment it takes 72 days the sojourn time of that activity. And let's say I want to reduce that activity by, let's say 99%, why not? It's going to be super fast. So I press the compute button and then I cross my fingers that the tool doesn't crash. It takes a while to compute. And there we go. And now the magic is also that you see that the color, of course, changed of the send fine. It's obvious because I reduced it with an insane amount, 99%. So when we now inspect the send fine activity again, we observe that it goes from 72 days to 17 hours in terms of performance. So that's much faster. And now the interesting thing is, okay, what effect does this have on the whole process, for example? And I can select the whole process in this panel on the right. And I can see that it has actually only a minor implication. So expected to drop from 290 days on average. The sojourn time is a very slow process to 240 days. That makes sense because, first of all, not in all cases this is executed. So this decrease doesn't always have an effect. That's what we see. It's actually, you can skip that send fine activity. Secondly, the major bottleneck for this process is also here at the end. So there you can see that, and that's, I think, the strength of this tool also conceptually, by exploiting this hierarchical property of these process models, you can actually anticipate changes in a certain part of the process and the potential effects on other parts of the process. But of course, it's a prototype and a large-scale evaluation of the accuracy still need to be done. So for the people that watched the second session, I now took a completely different thing that I optimized. So at least the people that are all in all the sessions, they know it's not a pre-recorded demo. Okay, then, oh, that was a live demo. Okay, then we have, of course, a Q&A for this session. So if anyone has any burning questions for this paper, by all means, shout or.
Thanks, Sebastian. Sorry, did I just, was there a comment somewhere? No, I think I heard something.
I mean, next time I can just talk for 10 minutes. I think I can manage.
Well, can you give me because I'm not necessarily deep into these into this area, give an idea, kind of the application scenarios. Of course, we're talking prediction, we're talking performance measurement. So what could you use this for?
I think in the ideal use case would actually be to assess not only the impact of changes when you are able to reduce one way or the other the service time of activities, but also to see, okay, if we would parallelize certain parts, what would be the effect then? So I would say if you look at the BPM life cycle, this is kind of part of the closing the loop in a data-driven manner, where you're monitoring the process, and now you would like to close the loop and see where you can improve. And so in the application area, ideally, process mining vendors would integrate this technology in 5 to 10 years, so that the users of the software can not only look, okay, what happened last year, but they can also anticipate whether certain redesigns in their process have a certain effect. Obviously, still conditional to the limitations that we discussed in the previous round. But I think that would be the long future goal. Also, we are working on interactive discovery techniques, where I also see we're also using process trees there. So that could also be interesting to integrate it there and to see if the models you're learning change due to addition of more data and integration of more data. Does the performance, expected performance, change?
Right. Okay, thank you. Any other comments, questions, feedback? I was interested in that PM4PY framework that you mentioned, that you're the originator of, but maybe we can save that for the next round.
Yeah, of course.
Can say a few words about that as well. All right, well, okay. If there's no other questions, then we move to the second presentation again, which is Azadeh.
Yeah. Now, could you see my screen?
Not yet, no. Yep, now it's here.
Welcome to this session. I'm Azadeh from Eindhoven University of Technology, and I'm going to present the main idea of our paper titled Detecting Privacy, Data, and Control Flow Deviations in Business Processes. Recently, data privacy issues are increasingly concerned by organizations and governments. Privacy regulations such as European General Data Protection Regulation or GDPR impose more strict privacy requirements. Based on this regulation, new privacy rules which point to who can access data for which purpose relate to multiple perspectives of a business process, because they are closely related to the task being executed or control flow perspective, the flow and processing of information or data perspective, and legitimate role allocation or resource and privacy perspective. So employees should follow these policies while performing activities in their daily work, but the problem is that real process behavior often deviates from the expected process, and it can open the ways for fraud or data leak. On the other hand, existing access control mechanisms are not sufficient for data protection, because these mechanisms are only preventive and independent of context, so they cannot check for which purpose data are processed after access to data has been granted. So in this paper, we address this issue by proposing an approach for multi-perspective conformance checking. In this approach, we consider three perspectives of data, process, and privacy in a business process. And this figure shows an overview of our approach. In conformance checking, we usually compare observed behavior and modeled behavior. To construct modeled behavior, we get three inputs. A process model with role information, a data model which relates the process logic to the data layer, and an organizational model which links users to their roles. And executed or observed behavior are recorded in the process log and data log. The process event log shows the start and completion of activities by specific resources, and data log shows who accessed which data fields at which time. And we combine all these 5 inputs and translate them into a large synchronous product model. And this model is the foundational model for conformance checking, and techniques exist to find the optimal execution based on a cost function that penalizes specific deviations. So in this synchronous product, totally synchronous moves represent expected behavior. We further distinguish 6 kinds of deviations. A move on data log happens when a not allowed data operation was executed. A move on process log happens when an unexpected activity was performed. A move on model happens when there are missing activity and data operations. A partially synchronous move happens when there is an ignored data operation for the executed activity, and in this case, the expected activity was performed by a legitimate role. A partially synchronous move with wrong role is the same as the previous one, but the activity was performed by an illegitimate role. And a totally synchronous move with wrong role happens when an expected activity and data operation were done by an illegitimate role. So the proposed approach allows the users to identify violations that cannot be detected by taking into consideration only 1 or 2 aspects. And by considering more perspective, our approach is able to find the context of the data accesses, and by reconciling the process data and privacy aspects, our approach can detect spurious data accesses and identify privacy infringements where data have been processed for unclear or secondary purposes by an authorized role. Thank you for your attention, and looking forward to answer your questions.
Right, thank you very much, Azadeh. Maybe you can give us a little bit more of an insight into how this is actually implemented, or what tools and technologies you're using there, just to add a little bit more?
Yeah. Actually, the main part of this work is the synchronous product model, which is a Petri net that with initial marking and initial places, and we want to achieve to final marking. So this is a very big Petri net, and there are alignment algorithms that we apply into this synchronous product. This alignment algorithm can find the least way, the best way with least cost from initial marking to final marking. And yeah, this synchronous product has 3 layers. One is a process model and data model. The second layer is process activities, and the third layer is the data operations there. So the main difference between these conformance checking with the existing ones is this asynchronous product model. We wrote an extension of this paper where we define formally all parts of pre-processing and post-processing and how to make this synchronous product. Then this work is under the review, and we will publish very soon. And also we developed a tool for that. For evaluation of this work, and also we applied that tool into an industry use case, as I mentioned in our previous session. And yes, we already implement all part of this work, and the result we will publish the result very soon.
And is this a standalone project, or is it part of a larger project setting?
It is a standalone, but the tool is in a Chrome framework.
Okay, thanks a lot. Any other questions, comments? We have a very silent audience. Oh. Can you show the conclusion slide, please? Is somebody saying in the chat? Feel free to open your mic if you want to, Matthias. All right. No questions there or comments, Matthias?